Today's lesson is kind of a review lesson on a lot of the math we've been doing as far as finding slope in algebra, but we're going to add to it the idea of parallel and perpendicular lines, which I'm sure you've heard of before. So remember, a parallel line, by definition, are lines that never intersect. So they look just like this picture over here to the left. So they're two lines that never intersect. But algebraically, let's say we weren't given a graph. Algebraically, how do we know if two lines are parallel? Well, when we see their equation in slope-intercept form, they will have the exact same slope. So that's really important. They will have the same slope. So for example, we could have y equals 2x plus 7 and y equals 2x minus 4. Because they have the same slope, remember it's y equals mx plus b, and m, the number in front of the x, is your slope. So I would say that these two lines were parallel because they both have a slope of 2. To figure out things about perpendicular lines, we first have to remember what a perpendicular line even is. So remember, by definition, perpendicular lines are lines that intersect at 90 degrees. And again, they look just like this picture over here. So they're intersecting, making 90-degree angles. All four of those are 90-degree angles. So if we weren't given a picture with perpendicular lines, how would we know if we are given two equations that those lines were perpendicular? So we'd have to check for two things. They have to have a slope that is negative or opposite in sign and reciprocal. So let's write that. They have slopes that are opposite in sign, which just means one is positive and one is negative, and are reciprocals, which means they are flipped versions of each other. So for instance, if I had 2 over 1, the reciprocal is 1 over 2. It's simply flipped. So let me give you an example of that. So an example could be if I had y equals 1/4 x plus 7. So notice that's a positive 1/4 slope. To be perpendicular, I would have to flip it, do the reciprocal, so that would be 4 over 1. And this top one was positive, so that one would have to be negative. And then the y-intercept can be whatever. So I'm just going to write -3. So 1 over 4 and -4 over 1 are opposite in sign and reciprocals. So these two lines would be perpendicular to each other. All right, let's review some more about being negative or opposite in sign and reciprocals of each other. So it says 3/4. So to flip that, it would be 4 over 3. The 3/4 is positive, so 4/3 has to be negative. Next one says 2. So we could write that as 2 over 1. Remember, when anything is a whole number, you can write it as a fraction by putting it over 1. So when I flip that, 2 over 1 would become 1 over 2. Since it started at positive, this one has to be negative. Now I would like you to try number 3 and number 4 on your own. For number 5, it's asking for the reciprocal of 0. Well, 0 can't be flipped over, so it's just 0, and 0 is not positive or negative. We don't write -0 or +0. So it's kind of a trick question. The reciprocal of 0 is simply 0. All right, the next little bit here says, determine if segments AB and CD are parallel, perpendicular, or neither. So we're going to do exactly what we just talked about to check. So I'll put it over here again. So to check if things are parallel, we would check to see if they have the same slope. To check if they are perpendicular, they have to be opposite in sign. So one is positive, one is negative, and reciprocals. So flipped versions of each other. If neither of those things happen, then we would say neither. So on example 1 here, it says segment AB is formed by -2, 3, and 2, 6, and CD is formed by -1, 0, and 3, 3. So we're going to find the slope of this line first using these 2 points. So let's label everything. So we have x1 and y1, x2 and y2. And remember, our slope formula is, I'm going to write it over here. No, I'll write it here. y2 minus y1 over x2 minus x1. All right, so if I plug everything in, so just follow what you labeled. We labeled y2 as 6, so this is for A, B. y1 is labeled as 3, so 6 minus 3 over x2 we said is 2, minus x1 is -2. So now if you need a calculator, grab one. 6 minus 3 is 3. 2 minus -2. Minus a negative is like adding, so 2 plus 2 is 4. So I get that the slope is 3/4. I'm going to do the same thing. I'm going to do my work down here for CD. But for CD, we have to make sure we use its coordinates. So I'm going to write those down here so I have some more room. Okay, so if I label those, my first coordinate, I'll make x1, y1. My second coordinate, x2, y2. And plug it into my formula. Remember, it's written up here in the top. So I do y2, which is 3, minus y1, which is 0, all over x2, which is 3, minus x1, which is -1. So 3 minus 0 is 3. 3 minus -1 is like 3 plus 1, so it's 4. Notice I got a slope of 3/4 up here for AB. I got a slope of 3/4 for CD. So I would say that these 2 lines, without even seeing them, I can tell that they are parallel. They will never cross because they have the same slope. All right, we're going to do the same exact thing for question number 2. So let's first find the slope of AB. So I'm going to use the coordinate 0, 2, and 5, 4. So we plug them into our slope formula. So let's label them x1, y1, x2, y2. Plug them into our formula, y2 minus y1 over x2 minus x1. All right, so my y2 is 4, so this is for AB. So y2 is 4, y1 we labeled as 2, x2 we said was the 5, and x1 was the 0. 4 minus 2 is 2, and 5 minus 0 is 5. So AB has a slope of 2/5. Rise of 2 and right 5. You are going to be doing number 3 and 4 on your own. I probably should have said this earlier. So you might want to leave some space to do 3 and 4 if you can write a little bit smaller than me, because you will need the space in the problem. All right, so that was just AB. So I know the slope of AB is 2/5. All right, so now I'll do the slope of CD. So I'm going to use 1, 8, and 3, 3. Okay, so for CD, my points are 1 and 8 and 3 and 3. So if I label, we'll let this first coordinate be x1 and y1, this second coordinate be x2 and y2. Plug it into your formula. I'll write it again. y2 minus y1 over x2 minus x1. All right, so my y2 is 3 minus, wants me to do minus y1, so 3 minus 8 over x2 is 3 minus x1 is 1. So 3 minus 8 is negative 5. 3 minus 1 is 2. So this slope is negative 5 over 2. So we need to compare. Oopsie daisies. Our first line had a slope of 2/5. Our second line has a slope of negative 5 over 2. So you have to think, what do you notice about these? Well, this first slope is positive, right? And the second slope is negative. So they're definitely opposite in sign. The next thing you want to check, are they flipped versions of each other? This is 2 over 5. This is 5 over 2. So they were flipped. So this is an example of a slope that is opposite in sign and reciprocals. So that means that these two lines are perpendicular. So my answer would be perpendicular. And I know that because they're opposite in sign and reciprocals. They're flipped versions of each other. Awesome. Okay, I would like you to try number 3 and number 4 on your own at this time. For to do your own. Now I would like you to try number 6 on your own. All right, we're going to jump down to question number 9. So on these, we're given actual equations, and we have to identify the slopes first and then determine, are these two lines that we have these equations for, are they parallel, perpendicular, or neither? So first, let's kind of review here. If our equation is given to us in slope-intercept form, that means it looks like y equals mx plus b. So remember the m, this number in front of the x, will be your slope. This is the number I'm worried about, right? Because I want to know, is the slope the same? Is the slope opposite in sign and reciprocal, or is it none of that, so it's neither? That's what most of your problems are going to be like. You're also given some of them where they're in standard form. So remember, we need to solve to get the y by itself before we determine what the slope is. So let's do a couple examples together. All right, so on 9 it says y equals 7x plus 2 and y equals 7x minus 1. So again, remember that number in front of your x is your slope. So let's identify that first. So the slope of this first line is 7, and the slope of the second line is also 7 because that number in front of both those x's is 7. So you can see here that the slope is the same. So that tells us our lines have to be parallel. Not as much work in these. It's kind of nice, huh? So these are parallel. All right, go ahead and try number 10 on your own. So first identify your slope. Figure out what is that number in front of x. Then you're looking, are they the same or opposite in sign and reciprocals? Go ahead and try number 11 on your own. For number 12, it says x plus 6y equals 30 and 3y equals 18 18x minus 6. So notice neither of these are solved for y equals, right? There's a bunch going on there. This first one's in standard form. So I'm going to solve to get this y all by itself. So the first thing I'm going to do is subtract my x. When I do that, I have 6y equals negative x plus 30. Then I'm going to have to divide by 6, and I have to divide everything over here by 6. So 6 divided by 6 gives me my y by itself, which is what I want. Now here, what this means, this is like negative 1x over 6. So negative, I'm going to write the 1. So that's like negative 1/6, the fraction. Then 30 divided by 6 is just 5. So now I'm left with this equation. So my slope is this negative 1/6. So I'm going to go ahead and write that here. So the slope of my first line is negative 1/6. The slope of my second line, first we have to get the y all by itself. So I'm going to rewrite this over here. All right, to get that y by itself, I would have to divide by 3. Now the y is by itself. 18 divided by 3 is 6, so you have 6x. 6 divided by 3 is 2. Awesome, it's already all by itself. So we have the equation y equals 6x minus 2. So the slope of this line, the number in front of the x, is just 6. So now you have to think, like, what's going on? We have a slope of negative 1/6 and a slope of 6. So first thing I would notice is one's negative and one's positive. Then you have negative 1/6, and remember, you can write 6 as 6/1. So these are opposite in sign and reciprocals, which makes number 12 perpendicular. All right, I would like you to try number 13 on your own. All right, let's go ahead and do number 14 together. So we have 3x minus y equals 2 and 12x minus 4y equals 4. Okay, so again, first things first, I have to get this y all by itself before I can figure out what the slope is. So let's solve this equation to get the y by itself. So first, let's move the 3x to the other side. It's positive, so to get rid of it, I'm going to have to subtract it, because 3x minus 3x is 0. I still have a negative y equals. Then I'm going to write negative 3x plus 2. I can't combine them together because one has an x and one does not. This is like a negative 1 in front of this y. So to get rid of it, I'm going to divide everything by negative 1. I'd be left with y equals negative 3 divided by negative 1 is positive 3x, and then 2 divided by negative 1 is negative 2. So this is my equation on 14. So my slope would be 3. So you have to solve it for y before you can determine the slope. All right, let's solve the second equation now to get y by itself. So first thing I'm going to do is subtract 12x and put it on the other side. When I do that, I'm left with negative 4y equals negative 12x plus 4. All right, I'm going to have to get rid of this negative 4, and since that's like negative 4 times y, I divide everything by negative 4. My negative 4's cancel, and I'm left with y equals. I have a negative 12 divided by a negative 4, so that makes a positive 3x. Then I have a positive 4 divided by a negative 4, so that makes a negative 1. So this is my equation, y equals 3x minus 1. My slope is also 3. So in this one, I got the same slope for both lines, which means these two lines have to be parallel. All right, go ahead and try number 15 on your own. that concludes your video on using slope to determine if lines are parallel, perpendicular, or neither. If you have any questions, let us know.